Okay, students, let's proceed to the next question, and it is about solving the second order differential equation given one solution, y1 equals x squared. So how are we going to find the general solution for this? Basically, we have derived a certain formula in order to find the second solution, provided that the first one is given. So using that, we can easily determine the second solution, and based on the first solution and the second one, we can generalize the final solution. So the procedure goes like this. So the solution is, as you see, this is a second order differential equation given. So in order to make y second prime coefficient 1, we need to divide the whole by x squared. So as you are dividing the whole by x squared, look, y second prime comes as it is, and this will be negative 4 over x, as can be shown, and 6 over x squared, y equals 0 can come. So clearly the coefficient of y prime is negative 4 over x. So the one we called p in our derivation of the formula is considered to be negative 4 over x. So using the formula, you see, we can have the second solution we can determine the second solution by using this one, y2 equals y1 into is a power of minus integral of p dx over y1 squared dx. So clearly y1 is already given because y1 is here, it is x squared, and we know what p is. P is a coefficient of y prime after you express the given differential equation in terms of this form. So directly substitute now y1 by x squared and p by negative 4 over x in this derived mathematical equation, and finally you see, you can have this one, y2, this is a formula I told you over here. So in place of y1, I'm now using x squared. So the integral of e is a power of minus of, your p is a coefficient of y prime, which actually is negative 4 over x dx. So here we need to square y1, so the square of x squared is going to be x to the power of 4, as you see. And from this we are having the following one, x squared comes as it is. This basically is a power of ln x to the power of 4, because negative can be cancelled by negative. Even you can take 4 out, so the integral of 1 over x dx, as you all know, is ln x, but 4 is out, so I can move this 4 up and write by e the power of ln of x to the power of 4. This is the property of logarithm, so you need to recall it. So the square of x squared makes x to the power of 4, and this integration, as you know, is x to the power of 4. Look, because here we are having e to the power of ln x to the power of 4, so x to the power of 4 can come, x to the power of 4 can come for the numerator, and in the case of the denominator we do have again x to the power of 4, so these two can cancel, and then x squared, the integral of dx can come because this makes 1. The integrand is going to be 1. And the integral of dx is x, and x times x squared is x cubed. So the other solution, or the second solution, is determined. So this one is a homogeneous differential equation. So we can now unite the first solution with the second one by linear combination approach, and then finally determine the general solution, as you see. So the general solution is y equals c1 y1 plus c2 y2, where c1 and c2 are arbitrary constant real numbers. So the final solution is going to be, now look, in place of y1, x squared is already given. In place of y2, we obtain that to be x cubed. So therefore, the final solution for this differential equation is going to be y is equal to, or y of x is equal to c1 x squared plus c2 x cubed. So let's go to the other question. Question number 29. It says, solve the following homogeneous second order differential equations with constant coefficients. So you have been given that y second derivative minus 7y prime minus 8y equals 0. So dear students, whenever you encounter homogeneous second order differential equations with constant coefficients, these can be done by using characteristic or auxiliary equation approach. So in the case of this, the dependent variable is considered to be m, and the order of the derivative is considered to be the exponent. So when we proceed to the solution, it looks like the following one. So the characteristic equation for the given differential equation is, as I told you, just change the dependent variable y by m, and then the order of the derivative here to be 2 minus 7 m here, because there is 1 here, so yeah, it works. Here we don't have derivative, so we don't have derivative means m is a power of 0 is going to come after minus 8, and m is a power of 0 is 1. 1 times minus 8 is minus 8 equal 0. Now this is a quadratic expression, so either you can use quadratic formula or factorization technique. Look, for instance, here, think of two numbers where their sum can be negative 7 and the product 1 times minus 8 minus 8. So think of two numbers where the sum can be minus 7 and the product minus 8. So clearly, as you know, these two numbers are negative 8 and 1. So we can factor this one as m minus 8 into m plus 1 equals 0. So if you multiple, you see these two, you can obtain the left expression. You can confirm it that way. So from this, the value of m is going to be 8, and or the value of m is going to be 1, minus 1 I mean. So the final solution is going to be the linear combination of e is a power of m1x and e is a power of m2x. So finally, the general solution is going to be given by y is equal to an arbitrary constant number c1 e is a power of 8x plus c2 e is a power of minus x. Here c1 and c2 are arbitrary constants. So proceeding to the next one, question number 30, we are having y second prime minus 4y prime equals minus 4y. So as usual, this is a homogeneous second order differential equations with constant coefficients. So it can be solved by using characteristic approach. So basically this is equivalent to 2y second prime minus 4y prime plus 4y. I just brought minus 4y to the left. So let's find the characteristic equation for this. So it's going to be m squared minus 4m plus 4 equals 0. So now, if you think of two numbers where their sum can be negative 4 and the product positive 4, clearly the numbers are minus 2 and again another number minus 2. So we can now write this as, you see, a square of a certain binomial expression, which actually is m minus 2 the whole square. That is to say, if you multiply m minus 2 twice, you will obtain the left expression. So this is going to be equivalent to 0, and from this the value of m that can satisfy this is only number 2. So number 2 is, you see, the root of the characteristic equation. Actually it's a repeated root, having even multiplicity, as you see, number 2 here. So once you have that, what you need to do is y1 is going to be the power of 2x. So how are you going to determine the other one? Because you obtain only one m value, and for that you have already taken one solution to be the power of 2x. So how do you determine the second solution? The second solution can be determined using this formula, but you already have determined what y1 is. You see, you can directly put y1 here, and the value of p is known. Clearly p is known, and so y1 is also known, so you can calculate this one. So from this, y1 is a power of 2x, and the integral is a power of minus 4 dx y1 squared, because as you see, your p is minus 4. So this is going to be is a power of minus makes positive, is a power of 4x over is a power of 4x, because these two must be squared. So finally, these two can eliminate each other, and finally the following can come. As can be shown, is a power of 2x into dx is going to come, because the two can cancel each other, and this makes x is a power of 2x. There is one tip that I would like to tell you here. If you are having a duplicated root, you better take, you see, x in front. As can be shown here, x is a power of 2x. This is basically an exponential function. This is also exponential, but had somehow linear expression as a multiplier. So the second solution is now determined, so the final solution can now be obtained by taking the linear combination of the two. So the general solution is y is equal to c1y1 plus c2y2, and from this what can follow is y is equal to c1 is a power of 2x plus c2x is a power of 2x. So this basically is the homogeneous solution. So when we unite the homogeneous solution with a particular solution, we can have y is equal to the power of 2x plus c1 plus c2x plus we are having now the other solution. The other solution can be written here as you see. So this is the answer because x is a power of 2x is already registered here. So y equals c the power of 2x into c1 plus c2x can be the possible solution. So coming to the next one, students, here come the third, you are given this. So again, this is a second order homogeneous differential equation. So let's now collect the expressions to one side. So as you are doing that, this expression again comes to be identical to this one because you see this negative 15y can be taken to the right, negative 12 dy by dx can be taken to the left. So this is going to be the last answer, the obtained possible simplified answer. So again, let's find the characteristic or auxiliary equation for this. You will obtain that to be 3m squared plus 12m plus 15 is equal to 0. So dividing the coefficient by 3, what comes here is 3m squared plus 4m plus 5 is equal to m squared plus 4m plus 5 is equal to 0. So think of two numbers where their sum can be 4 and product 5. It's very difficult to find that in the set of real number. So let's solve this one in the set of complex number. So as you see, using the quadratic formula, m is negative 4, which actually is negative b, plus or minus b squared, which actually is 16 times 4 times 1, 4 times 5, 20. And mind you that there is minus in between. 2a is 2. So as you are simplifying this, minus 4 over 2 is minus 2. So plus or minus comes as it is. Radical 16 minus 20 is minus 4 by 2, 1 by 2 minus 2. Minus plus or minus 1. So you are having minus 2 plus or minus I as the values of m. So m does have two solutions. One is minus 2 plus I and the other is minus 2 minus I. Don't worry about that. Just consider alpha to be minus 2 and beta to be 1 because alpha is considered to be the real part and 1, which is written here, is considered to be the imaginary part. So as you are doing this, you see alpha is minus 2 and beta is 1 in the derived solution as you see. And next from this, what comes is the solution way of writing. We obtained at the beginning that you see the solution is a power of alpha x into c1 cos beta x plus c2 sin beta x, but we knew what alpha and beta here. So alpha is basically nothing but it is equivalent to minus 2 plus or minus I, and here beta, which actually we called as m, is 1. So when we put 1 there, it will be as you see. So finally, the general solution for this differential equation can be written in terms of this one. Y is equal to e to the power of minus 2x into c1 cos x plus c2 sin x. So everything is now done. So it is done according to this way of procedure. I hope you have understood it. Thank you.